So SQL for data analysis for week 2, and we intend to cover statement and clauses, basic aggregation, SQL operators, and so on and so forth. And I believe that you've, to some extent, understood last class. If you don't, please watch the video again, and always ensure that you take notes. You write, you jot things down. You don't just, you know, watch it as if you're watching a movie. No, you jot things down. Try to understand what you jot down. Feel free to reach out to me to ask any question you have concerning that. I will always be ready to assist you. The worst that could happen is that I may not answer you immediately, but eventually I will answer you. So let's quickly take a look at the things we have here: statement and clauses, basic aggregations, SQL operators, tables, merging of tables like inner, outer join, left join, right join, what they are and their uses. In this session, we are going to be very hands-on. So ensure you get ready to, you know, practice with me. So the first thing now is that we need to have access to our database. I believe by now that you have installed Postgres on your laptop. The data, what's it called? The database server that we'll be using for this uh, lesson session is Postgres database, or Postgres server rather. Is the Postgres server we'll be using by default. It's not that we cannot work with MySQL and all that. If you have that, it's still good. But in order for you to be able to follow properly, ensure you use the manual for installing Postgres to install Postgres on your laptop, and then follow this the instruction here so that you will not be confused. So now we have to fire up our server, and for we to do that, we have to go to local disk. The instruction on how to, go to the server is also on the Postgres installation manual that I sent to you guys. So all you have to do is go to C. This is local disk C, and when you go to C, go to program files. When you get to program files, look for Postgres. It's somewhere there. Look at it, is Postgres SQL. And then this is 13. That's version 13 that I'm using. So all you can do in order to the directory, if you want to copy, you can just click on the bar here. This search bar, or no, it's not a search bar. I think it's a directory bar. You can click on it and then you can copy it out, right? But even though you copy it, I don't know, sometimes terminals can be very crazy. So on the search, tab here, you type your CMD. So we want to bring up the command prompt, but we want to ensure that we run it as an administrator. That is very essential. So we are going to the server and we're going to make changes to the server. So it's better you log in as an administrator. So, and we have to open our terminal as an administrator because it's our terminal that we're going to use to access the server. So we say yes. Okay, we've said yes. And then the next thing, we need to get to this location, this folder 13 here. And to do that, we do cd. Cd is a command that we use to jump from one directory to another directory. So we want to jump from Windows System 32 now to folder 13 under local disk program files PostgreSQL. So we do this backward slash, and then we type program files, and that backward slash, type Postgres SQL, another backward slash 13, right? Then you hit enter. So you can see that we've jumped from this folder now, Windows 32, System 32, to now we are in this folder, Program Files, PostgreSQL 13. So having done this, the next thing we should do is we look at because we need to be able to log in. So we look at our login details. So to log in, we see that there is a command we use in logging in. So we say psql -h, which is the host, and then the IP address of the host, 127.0.0.1 is localhost. That's your computer. And then -u, which is the user, that's the username. Then we put the username there. the name of the user is Postgres. So following this, what happened? Where's my terminal? Okay, it's here. So following this, all we just have to do, we type it, right? So we type PSQL -H 127.0.0.1 -U Postgres. Okay, so here remember PSQL is the command we use to log into the Postgres SQL server, and then -H here meaning the host. So the host IP is this, and then we have -U here, which means the the username. So the name of the user is Postgres. So once we have it like that, we hit enter. So it's asking us for password. While you were installing your Postgres, you remember the server password, username and password you entered. That one, I can't help you. You either know it or you don't. And then you have to face the headache yourself. So because on the instruction manual, I think I also kept a warning there that make sure you remember the password. So here I enter my own password and then voila. That's our Postgres server for you. So we can check the list of databases we have on this server. And then here is it. These are the databases that are currently there. And then we can also check the list of schemas that we have, right? So by doing /dn, /L is for the list of databases. Then /dn is for the list of schemas, right? So the difference between a schema and database is that a database can contain several schemas, and schema can contain several tables. All right. And remember, we talked about table. We said table is made up of what? Columns and rows, just like in your Excel sheet. Okay, so now we move further to, we can create a schema. All we have to do is create a schema, and then we'll call it book, right? Can hit enter. Now, if you do /dn and check, it should be there. I don't know why it's not yet there. Let me see. Maybe because of the comma syntax. Okay. Let me check. Should be there. Okay, let me create another schema. Let's say cookbook N, and then hit enter. And then let's check. I don't know why it's not recognizing it. It should be part of the list of schemas by now. Though sometimes the server can be the one taking time, to create it. That could be the reason why. So we are going to also look at the create schema. Then the name of the schema is just a will I call it a general way of doing it, but there is a more standardized way. And in this case, we have to say create schema if exists, right? Or if not exist. If not, in this case, is to check if the schema doesn't exist, and then we'll call it cook book, right? So you can hit enter, and we check again. Still don't know why it's not yet responding. It should be there, but let me check list of databases. Okay. All right. It should be here, but I don't know. We'll check. I think I'll have to troubleshoot this. Let me pause what I am doing, pause my screen, and also pause the recording. So here's what we're going to do. Remember, we've said we'll use this /small letter L to list the databases, right? and then we use the /dn to list the number of schemas, and then we can create schema, right? And we said we can use this command, create schema. Can call this cookbook, just like this. So if it works, you should see this command regenerated create schema. So if you do /dn, now you will see that cookbook is now part of the schemas we have here. All right. So, but then even though this command looks good, but it's still not perfect. Why is that? There is a more intuitive or standardized way of doing this, right? So to do that, you said create schema, if not exist, cookbook, and then we have that, right? So this actually checks if the schema exists before creating it. This will throw an error, and then the one at the top here, the very first one we ran, will also throw an error, but we are going to compare their errors. So for this one, you hit enter. For this method, you hit and enter. I don't know, why is it not responding? Yeah, so you can see the error it gives. Schema cookbook already exists. It's saying that this name cookbook, it already exists. So it's going to skip the command create schema. But then if you now have the same thing, however, we didn't use if not exist, right? And then we hit enter. We can see error schema cookbook already exists. It will stop there. So it's not going to add skipping the command create schema. So this one will just say schema already exists and then it will stop. So they are both the different ways of creating a schema. However, this is more like a professional approach to creating a schema. So the next thing to do, here is create table, right? So we can also create table. For instance, we want to create a table called customer, and this table we want to create has column. The first column is title, text, and title. The second column is year, and then we put their data type. The title is text, the year is date. Those are the two data types there. So we can actually do this. Let me see. Seems okay. No problem. You know how to come on now. So we have that. I think my screen has officially split itself into two, which is good. So we can create table if not exist, right? So we are creating a table now. Remember that every table is tied to a schema. If you don't tie it to any schema, you will get an error. Cookbook dot customers, you open bracket, title, type text, comma, then year, date, and then you close it, then you put a semicolon. So basically what we have here, as you can see, create table if not exist, cookbook.customers, the columns in the customer table is title and then the year, right? So you hit enter and then it has been created. The table has been created, and I will show you that it has been created before we start deleting some of the things we did here. So the first one we'll do is to check that the table actually exists. So how do we know? We can use the select asterisk, meaning all columns, though it's not right, but I'll tell you why later in the future, not now. From the table, and how do we get to the table? You call on the cookbook first, cookbook dot the table customers, right? And yeah, so you do this, you can see this is the table. You can see the first column is title, the second column is here. All right. So that is how you query the table, right? But we'll talk more about querying data from table. By then, we would have ingested data into the tables. Then the tables will create, and then we can now start talking about, querying data from those tables. So far, so good. We've seen how to create schemas, and we created a schema called cookbook. And then after creating it, we compare the generic way of creating it, create schema cookbook, and then we compare it to the professional way of creating it using if not exist. And also, we move on to creating a table, a simple table called customer, and the table has column title, and the data type of that title is text, and the table has another column called year, and the data type of that year is date. So the last thing we'll now do is that we want to remove the table, and we also want to remove the schema. So the first thing you will do, you don't start by removing the schema. If you want to remove the schema, you run into an error. Let us see. Say drop schema cook book. Hit this. You see, you cannot drop schema cookbook because other objects depend on it. So it's referring to the table. Now give you more detail and say table cookbook, customer table depends on the schema cookbook. So you always have to drop the tables, all the tables in that schema before dropping the schema. So in this case, you say drop, want to drop the table, and then we chain the schema name to the table we want to drop, which is a customer. I think customers, right? And yeah, that's it. We drop the table. So if you run the command we ran earlier, which is the select from cookbook.customers, if you run it again, it's going to be an error. It's telling you that that table does not exist anymore. So you can now at this point drop the schema, drop schema cookbook. You see, we've also dropped the schema, and then we can check by doing /dn, and we see that the schema is no longer there. So yeah, basically this is about creating databases and schemas and tables, right? So we'll move on to the next thing. Here now, we want to I want to guide you on how to ingest data into the database, right? And the data we'll be using, I think we have two of them. Let me see. We have two of them. The data we'll be using, we have two of them. We have two of them. One of them is called Consumer Complaint 1, and another one should be Consumer Complaint 2. Yeah, those are the two data we'll be using. So now we are going to create, right? So what we'll do here is that we are going to create a table, right? But before we create this table, we have to create a schema. And the name of the schema is called my schema. Then the name of the table we are creating is called issue, right? So when we do that, after doing that, we'll come here and ingest the data using this command. So we now ingest the data right from the desktop, right? So right from the desktop, we ingest the data into the database. So the first thing we do is to create the schema, right? So we say create schema if not exist. So what's the name of the schema? The name of the schema is called my schema. That's the name of the schema. So you hit enter. We've created it. Check it. Does it exist? Yes, it's there. It's called my schema. So having created it, what's the next thing we do? We move ahead and create the table. Remember, when we're creating the tables, we create the columns with it, right? So create table if not exists. and we call this my schema dot issue. You open the bracket. So the name of the columns on that on the CSV. So we have their names here on this code. So the first one is date received, date received. So the data type is date. Don't forget, comma. Then the next one is product name, product name, right? And then this one is a varchar. That's a variable character. It's a variable character, a varchar. And then the length of the characters in it is set to be 80. I chose to put it that way. You can make your own 100, you can make it 50, right? So it's set to be 80. But normally it should, ideally, you should be able to guess how lengthy the characters in this, how lengthy the character could be that could fit in. Because while you are also doing that, you are putting into consideration the memory space it will take to store those data, right? So we'll move on to the next one, which is subproduct, sub product, subproduct, say varchar. So once we do the ingestion today, I don't know if we'll touch any other thing. I think I'll have to, stop there so that you go step by step. It will not be too much for you. So, and then we'll continue with querying the database, then from there to making joins and all that. So the next column is subproduct, and this one has 100. The next one is issue, and this one is varchar, comma, and then we'll have 100 here as well. So we have the sub issue, we have sub product. This one is sub issue. So I almost missed the name of the column, sub issue. Then we'll have the complaint ID, right? So complaint ID is an integer, it's an int. We have the state, that's the state name. And this one is a varchar. I don't know the length. Let me see. The length is 10. Then we have primary key. So basically what we are doing now, we are now setting a particular column to be our primary key. And the column we are setting to be our primary key is the complaint complaint ID, right? That's the one we are setting to be the primary key. So you can actually, at the point of creating your table, when doing the necessities or the necessary things with the column names, you can also ensure that you pick out the column you want to make as a primary as the primary key. By now, I believe that you know what primary key is from what's it called? Is it foreign key? So this has been created. We can check our schema. We see my schema is there. We can try to, query the table and this. So we have my schema dot. The name of the table is issue, right? You can see the table name. You see the name, date received, product name, sub-product, sub-issue, complaint ID, state. So there is no data there. The rows are 0. Now, one of the things I also need you to understand in SQL is that if you notice, I was typing them, the column names, they were starting with capital letter for the first letters, right? But by the time you create it in Postgres SQL, it kind of convert everything into small letters, right, for consistency. So having done this, the next thing we have to do is to ingest data into this. right? So all we have to do here, the first thing we did, we wanted to, created a table called issue. So the first thing we did is to create a schema called my schema. After creating my schema, we came forward to create the table. And then in the table, we have all the necessary column names. And then for the column names, we ensure that the data types are defined, right? So after doing that, the next thing now is to ingest data. We want to ingest data from our desktop into the database that we have, into the table we have created in the schema, on the schema. And then to do that, we are going to use the copy command from Postgres. There's a command called copy. So the backward slash and then copy. So what copy is going to do is to copy this data from the CSV that is on the desktop into the data table on the database. So we'll do my schema dot issue. So we have to still tell it. We are not going to assume, right, that Postgres should know everything. We have to still tell it the names of the columns that we want to feed with data, right? Because sometimes you may want to deal with only some columns, not all of the columns. But here we are dealing with all of the columns. We say date received, received, say product name, comma, sub product, comma, okay, issue, issues, comma, what? So we have to check again. We have sub issues. Was it like that? We have sub issues. We didn't have issues and sub issues on the earlier one. Let me quickly check. The one we created earlier. We have sub issues. And that was it. We didn't have issues and sub issues. We only have sub issues. Okay, we had we had issues and sub issues. So since that is the case, I'm going to recreate this. I'm going to recreate it. So I'm going to first drop the table, right? I'm going to drop it, drop table, because there is an error on the table already. The number of columns are incomplete. So drop table, my schema dot issue, right? That will work anyways, but I just want us to maintain consistent. My schema dot issue. Yeah. So we dropped it. Now let's see if we can bring the command back up using the arrow key, the up arrow key. So we are going to introduce the column that is missing. And I think the column is missing right before sub issue. We have issue, and the issue is it has a variable character, and this one is 100. So we have issues, we have sub issues. Hit enter. We have recreated it. Now that we have corrected the error, we'll go back here. Go back here. So there are two things we can do. We can either type it out, we can copy and paste, but I am not, you can copy the code and paste it, but I don't think it is a good idea because you need to learn. So it's better you type it so that you can be making mistake and knowing what is wrong and what is right. My schema dot issue and then date received, comma product name, comma sub product, comma issue, comma sub issue, comma complaint ID, comma state. So having done this, we are saying copy into this table, into these columns in this table, right? But from where? We're now saying from, we now put the directory, the what's it called? The directory, that is the point where the this thing is. So we'll say C, excuse me. We now go ahead and then we have C and backward slash. So we are picking the directory users del backward desktop backward customer consumer, right? Consumer complaints. Consumer complaints 1.csv, right? So, and you have to also be observant of something else, that there are kind of a this thing, what's it called? An apostrophe or a quotation mark, a single quote on them. So you take consideration of the single quote, and then after that, you move to take consideration of the single quote. After that, you will move to typing delimiter. You know why we're using a delimiter? Because it's a CSV. The CSV has a delimiter. So, and we are telling it that the delimiter on the CSV is a comma delimiter. So we put the comma inside the single quote so that it can know. That's the only way it can, effectively fetch the data. So do CSV and then header. We are telling it that it's a CSV. So once you do this, hit enter. I hope there's no error. Oh, there's an error. Column date received of relation issue does not exist. Date received does not exist. Date received of relation issue does not exist. I hope I didn't make any mistake. I hope issue, sub issue, date received. Yeah, everything seems fine. Why is it now saying it doesn't exist? Okay, let's check the CSV. Maybe it's talking about the CSV file. Right. Let's check the CSV. So I think that shouldn't be, because I mean I've used it before. So it's like it's saying that that doesn't exist in the CSV. Maybe I have made some changes to it and I saved it without knowing. So let's check it, because it's complaining about the date received. We have date received, right? We have product name, we have sub-products, we have issues, we have sub-issue, and we have complaint ID, and then we have state. Come on now, everything is there. I don't know why it's throwing this error. Let me check again. Column date received of relation issue does not exist. Does not exist where? That's the question now. So there, before we continue, I think we should query the table once again, right? So we are going to query the table once again to see where the issue is coming from. Is it, I mean, we've queried the table before, so we can actually look at the titles here. Date received is here. Oh, okay, sub issue is here, but issue is not there. So let's check. I thought we solved this. Select this from my schema dot issue. Let's see. So we have the issue, we have the sub issue, we have the date received, we have the product name, we have the sub product, complaint ID, state. So we shouldn't be getting this error. Shouldn't be getting this error. So if we're having this error, I don't know. I can't say it's from the database side. Let me run it one more time. Okay, I think I noticed something. I just hope that's the issue. Still throwing the same error. So let me check the command again. I think it's the command, right? So users, Dell, desktop, consumer complaints, the CSV, delimiter, comma, CSV, and header. So for this, we'll have the date received, product name, we'll have sub-products, we'll have issue, we'll have sub-issue, we'll have complaint ID, we'll have state, right? Okay. I'm trying to, think it through, like where could the issue come from? So maybe, let me just correct the column names. I don't think that should be the issue, but let me just correct the column names because I have actually run these commands and I have worked on it. So I'm actually surprised. So we have issue, sub-issue, we have complaint, ID. Okay. ID of state. Okay, let's see. I really do not expect this to be having an issue. But if it does continue, I don't understand this error at all. Column date received of relation issue does not exist. Does not exist where? Uh, okay, here's what we'll do. Let me see. Maybe I'm the one making mistake with the command without knowing. Well, let me just copy this and then try it and see. The same thing. So the error persists. So I'm going to figure this out. Okay, let me see. Um, so, hello. Okay, let's pause. And, so, the issue we are having, I think, has been sorted out. The issue we're having was in the misspelling of the column names. The received we had, so I recreated the table, right? I dropped the table. After ingesting the data, I dropped it and then I recreated it. So the issue we are having is here on this receive. So on the column, date received, the received is spelled as IE, and then while ingesting the data, we named it as EI. So, and Postgres is sensitive to the name differences. That's why it's throwing an error. So the table has been recreated. It's empty now. I'm going to ingest it so that you see the error I'm talking about. Okay. Uh, so you see the table is empty. Now I'm going to, ingest the data. I'm only using the up arrow key for the previous commands I've entered so that I can just hit it again and that will be it. I don't know why has it gone that far. Okay, so this is the command here. You can see that this one is IE. So this is the corrected one, but let me change it so that you see what I'm talking about. We come here. So we do EI. So remember here it is IE, here it is IE, and then on the command to ingest the data, we are saying EI. So if you hit enter now, it should throw you an error. So you can see saying date receive of relation issue does not exist. So we'll have to correct it. We'll have to correct it. So the column's name must be spelled and it must be consistent, right? So we have to put IE here and we hit enter. You can see that it's telling us that over 65,000 records have been copied. So when we do this, that's for this slide, right? We go ahead and do for, because we have two data sets and we want two tables, right? We have two data sets, we want two tables. So we'll go and ingest the second one. I don't think the second one should give us any headache. Okay, so we just come here. Remember, the first thing we do is to create the table. So create table, if not exist, and then we'll do my schema dot consumers. Remember, the first one is issue table. The second table we are creating now is called consumers. So on this, we have the date, right? And the data type is date, comma, we have company, and the data type is varchar. And then we can put 100 as the length of the characters that we're putting there, the characters. Then we have the state name, and then this one also is a varchar. And we'll put 10, state name to be 10. Remember that the state name in the first table is also, we put the length of the character to be 10. So all this is to help us to maintain consistency. You are not having the same thing running, different things running here and there. So we also have the zip code, which is varchar, and this one is 30. And we have the tags. The tags are also a varchar, right? That one is 100, comma. So let's quickly check. Is there anything left? Nothing. So we'll come back here so you know what we are doing now. We are creating a second table, which eventually will ingest the second CSV. We ingest the second CSV into this table. So consumer consent provided is also another column. Consumer consent provided, which is also a varchar. This is 60, comma, submitted via submitted via is also a varchar. So we now have date sent to company. Date sent to company, which is date. It's also a date, the data type. So we have company response to consumer. Company response to consumer. So we have to be careful how we spell it because we don't want to make mistake. Any mistake now during ingestion, it will lead to an error. So have varchar, and then have timely response. Timely response is also another column. It's also a varchar. This one is 100. right? Comma, then we have consumer disputed. Consumer disputed. This also a voucher. Then we have complaint ID. Complaint ID, which is an int. And then we'll have the primary key here as well. You can decide to set the primary key here to be the complaint ID, right? Or we can also decide to make it a foreign key in this place. So we have to decide which table is a dimension and which table is a fact. But then this is just for an example. So forget about fact and dimension. These are just simply two tables that we are linking together. Okay, so let's make this one foreign key. And then we are saying the complaint ID is the foreign key. Complaint ID is the foreign key. So we hit enter. I hope. Okay, I think it has an error. With the error syntax line ratchet 200 complaint ID int foreign key. It's supposed to be double, not one. Okay, let me call it primary. Maybe that's why it's throwing an error. Then it shouldn't anyways. Yeah, that's why it's throwing an error. So we'll get there's this e-commerce data set that is well organized to build a more robust table. We'll get it and use it for something like this one is just some two CSV files that we just want to use to, do examples, right? So we can select from this table to see that it actually exists. My schema dot consumers, right? So we have them here. So the next thing we do now is to ingest the data. So we take the data from we take it from the desktop, we load it into the database. So to do that, remember we'll use our copy command. And then we are copying into my schema dot consumers, right? Consumers, and we begin to list the tables. So we have date, we have company. Remember, we have to spell them right. If not, you will run into issues. State name, zip code, tags, consumers, consumer consent, provided, submitted here, and what date sent to company, date sent to company response to consumer, company response to consumer, timely response, consumer disputed, complaint ID. So we have finished spelling them, listing the column names. So from now we have to put the address, where the CSV file is located. C /users /del /desktop /consumer complaints 2.csv comma, and then we'll have delimiter, and then we'll have a comma, and then we'll have a CSV, and then we'll have a header. Okay, I hope everything works fine. Because if it doesn't, oh, this also works fine. So we have been able to load the data. So let us quickly query it and see from this particular table we just loaded, my schema.csv. What am I saying? Consumers. So you put limit because it's a lot of information so that you don't go and load everything. Limit 10. You can see those are the data that we uploaded. The same thing also applied to the first one. Remember that one, the table name is to the first table is issue. You can see this is the first table. So we're going to stop here so that we'll continue later with the next which is querying the results in the querying the table, right? So we're going to continue with that. We're going to continue with that, but for now we'll stop here. So thank you so much for your time. Ensure you practice. Let me know how you were able to ingest the data from your desktop. And then the second phase of this will come where we'll talk about, querying the data, manipulating them, joining them, right? So yeah, that will be all for this one. Thank you.